Hey, it's Carlos Ramirez, owner of NVSAUDIO in Roselle, New Jersey. It's crazy that I even have to make this video, but after the things that I went over on this slingshot, I realized that what we thought was common knowledge here actually is not. So in the first part of the video, I quickly looked over it so I could put together a quote for the client, let them know what was wrong, what could be fixed, what couldn't, and it turns out that nothing can be reused. The amplifier, one amplifier is blown, one amplifier is wrong, so we have to redo the entire thing. The power wires that they used was wrong, everything was the wrong gauge. So then what happened next was completely crazy to me. I guess he called the shop that did the previous install and they agreed to take some of the equipment back. So the installer actually showed up at my shop, the installer that did the work, and I had forwarded the customer the video so he could show exactly what was done wrong. The installer got upset because I called him lazy and told me that there's no issues with grounding to the frame of the bike. He's done at least 20 of them the same exact way without any problems. So the reason I'm making the video is to explain something that I thought was common knowledge that obviously is not. So on this bike from factory, there is a ground wire that goes from the battery to the frame of the bike. That wire is only good for the amount of current that the bike can handle for its factory installed electronics. So if you add up the fuses in the fuse holder, that'll let you know what the current capacity of the wire. It's the same thing on a car, it's the same thing on a Harley, it's the same thing on a Slingshot. So the factory ground wires that are ran to the battery are only meant to handle the current from the factory equipment. Once you add a ground to the body of the car or the frame of the bike or the frame of the Harley or the frame of the Slingshot, the ground wire from factory is now providing the current to your amplifiers along with the rest of the stuff that's on the bike from factory. This bike was designed to have 140 amps of current maximum through the factory ground cable. So now this goes from the negative of the battery to the frame of the bike. Any additional, whether you add lights, strobes, stereo, amplifiers, if you do not run your own lead to the negative post of the battery, you are sharing the ground that the bike has. So you can do it that way by upgrading the ground. So if you go with a thicker ground wire, if you run multiple ground wires, basically doing the big three, then you're increasing the current capability of the frame of the bike. So up to a certain point, you can get away with it. But to avoid all that, anything that you add, just run it back to the negative post of the bike. So when he told me that there was nothing wrong with what he did, I asked him why he didn't run, and I'm hoping he's watching the video. When I make videos, I never name shops, I never name people. I make videos so people can do stuff the right way, justify why we charge what we charge, because obviously it would take us longer to do the job than it took them to do the job, because we're going to take more time and map everything out. I haven't even given the customer a price quote yet because I'm still going over stuff and finding mistakes. Yes, there's more mistakes. Wait till you see what that's about in the video. So I asked him why, so I hope he's watching the video so maybe he can learn. I'm not being malice or facetious. You did it wrong, and I'm trying to teach you and everybody else how to do it properly. So I asked him why. He said it wasn't laziness. He cleaned the paint on the frame before he mounted it down. First of all, the amplifiers were too tall to go under the seat, and this is something that escaped my attention the first time around. You use thick ass nuts to space the seat up so the seat would clear the amplifier. That is clearly wrong and unsafe, because when they manufactured the bike, they made the seat bolts a certain length so in case of an accident they wouldn't shear or snap. You went and lifted the height of the seat and then used the same factory bolts, so if it was 18 turns to get the seat to bolt down, you're now at 4 or 5 turns to make room for your amplifiers, which makes the bike unsafe in case of an accident, because these bolts are designed by people much smarter than you and I, and they're designed in a certain way, in a certain length, where in case of an accident it won't shear or break. You went through that calculation out of the window and made your own getter ass spacers out of, I'll show you. This is not a slingshot nut. This is a nut that was placed under the seat to space the seat up to allow the amplifier that was way too big to go under the seat to go under the seat. So if I count the threads in here, there's at least 12 turns that the factory bolt no longer gets. So it's basically leaving the bolt loose 12 turns. Not safe. So he said that he cleaned the paint on the frame before he grounded the amplifiers. Well, the issue with that is you use aluminum wire. So it means the amplifier is getting half the amount of current that it wants. Then on top of that, I asked him why he didn't run the wire to the battery. He said he didn't have enough wire. So you don't have enough wire to do the job properly. So you take a shortcut on top of a shortcut on top of a shortcut. Not fair to the client, not the right way to do it, not safe. And on top of that, I know for a fact you used an amplifier wiring kit that's designed for a car. So we've all taken shortcuts in the past. Since the wire's too short because it only comes with 3 feet of ground, this is a bike, not a car, so I know it came with 17 to 20 feet of power wire. So you ran the power wire to the battery. Why don't you take the extra leftover 8 feet of wire, tape it black, and run that to the battery? So you could have had a 8-foot run of black and an 8-foot run of red, because I know you use an amplifier wiring kit to install the amplifier. So you should have had enough wire left. Even if you didn't have enough black, you could have made it out of red. So then on top of that, the reason the battery arced out, oh, and this is what he did to keep the nut from spinning off the terminal. It just wrapped a big ass wad of tape around it, but it didn't work because it's still loose. This wire looks like 0 gauge, but it's not, because A, it's aluminum, B, it's mostly insulation and no wire. Look at that. All plastic, no wire. So inside the 0 gauge jacket is less than 4 gauge worth of wire, and it's aluminum, so you might as well call it 8 gauge. And this runs the entire bike and the entire system. So now, wherever they got the battery mounting plate from, very high quality product, awesome plate. The plate is so nice, it comes with provisions to mount the factory fuse block onto it. So they gave you the tools to be able to do the job properly. So now, on this kit, battery mounts in a tray like that. So now, since the tray is smooth and the battery's smooth, the battery is sliding around, and then this part of the tray grounded out against the positive post, and the mark is right there. That's where it welded itself. And the wire caught fire. This could have happened while the customer was riding. So this grounded out against here. Now, if you pay attention to the way this is designed, this should have never been used. The people that make the plate are smart enough to know, well, it won't even come off, that you're going to use this type of battery. So there's an indent in the battery right there, and it happens to be the same exact thickness of the plate. So when it's tightened down, the plate cannot slip and touch the positive terminal if you use the top post, but it can twist and touch it here if it's not positively tightened. So if we were to do it this way, and we wouldn't, to protect this, we would wrap this in tape and insulate it, or use some sort of insulation, or cut a plastic hose, something. Just a little bit of common sense, because you see how close that sits to that terminal. We would have never used that terminal. We would use the top terminal, because there's nothing but plastic up here, nothing for it to, plus once this is set in place, it can't hit here. And this comes with 2 plastic caps. We would have left the caps on, so this would have never happened. But if we had to, we would just wrap this in tape or some sort of plastic to keep it from hitting this. Stuff happens. It could have been a little bit smarter. Then on top of that, this plate is completely smooth. The bottom of the battery is completely smooth. If you had added Velcro to the bottom of the battery, so the fuzzy part of the Velcro here, the other part of the Velcro here, and stuck the battery onto the plate, with the 2-inch heavy-duty Velcro that we use here, you're not twisting this battery at all. It's not moving. It would have kept it from moving, and then you can insulate the bracket. So it would have been safer without using some of the fancy tools that we have. It's just common sense stuff that anybody could do. Would have avoided this entire problem. So now, let's get down to the power calculations. So We're going to use gel audio for this example because the one piece of good wire that was on the bike was gel audio wire. Right on the wire, and this is the wire that was grounding the entire Slingshot. So right on the wire, it says right there, 60 amps of current. So right there, it's telling you what the wire can handle. So it's telling you that this wire can handle 60 amps of current. So there's a Taramps amplifier in the bike and a Rockford amplifier in the bike. So I went on both websites to download the specifications. So the Rockford website recommended a 100 amp alternator and a 140 amp fuse. Maximum current draw from the Rockford amp was 140 amps. Maximum current draw from the Taramps amplifier was 100 amps. Then you add the current draw from the bike itself. So you're talking over 240 amps of total current draw. They only used a 200 amp breaker for everything. Fine. The battery cutoff switch that they put in to keep the battery from dying overnight is rated at 100 amps of current. So once you add the bike current to the amplifier current, you have over 400 total amps of current draw. No wonder the inside of the switch was melting. And on top of that, the bolts were loose, which also creates heat. So we have a 100 amp battery cutoff switch, which you ran the positive output of the battery through the switch and then back out to the bike and the amplifiers. So you have a 100 amp switch on 200 to 40 amps of current draw. Not done properly. Then you ran cheap Harmony Audio aluminum, copper clad aluminum wiring, which is only good for maybe, I'll be generous and say 100 amps of current. To do this properly, and we're using we use Stinger wire here, but we're going to use gel audio specification because A, I love the fact that they have it written on the wire, so you have no excuse for not knowing how much power the amperage the wire can handle when it's written on the wire. So we went on Gel Audio's website. Their 0 gauge is rated at 250 amps of current. Their 2 gauge is rated at 150 amps of current, and their 4 gauge, which we have here, is rated at 60 amps of current. So if you wanted to do this properly using gel audio wiring, each amplifier should have had minimum 2 gauge wire using gel audio wire. So you could have gotten away with 4 gauge, but it's a little, you could have gotten away with 4 gauge on the Taramps amplifier because it's closer to 100 amps. But on the Rockford, you would definitely needed 2 gauge of the gel audio oxygen-free copper wire because the amp draws 140 amps at full tilt and the wire can support 150 amps. So from the circuit breaker to the battery, you would have to add the 150 and the 60. So then you would needed oxygen-free copper gel audio 0 gauge wire running from the battery to the distribution block or the circuit breaker, and then from there you could run a 2 gauge to the base amp and a 4 gauge to the 4-channel amp. That's using the equipment that was there. Now, if you sat down with a piece of paper and went out on the websites, so I went on Gel Audio's website to get that information, I went on Rockford's website to see what the amplifier needed, and went on Taramps' website to see what that amplifier needed. So just takes a little bit of research to be able to do it properly. Anything that I've said, you can fact check. You can go on Gel Audio's website and check the wiring. You can go on Taramps' website. The amplifier that they chose to use was a 1200.4 2 ohm, and they had a Rockford Punch 1000. So Rockford Punch 1000, a 1200.4 2 ohm by Taramps. The wiring that they used was Harmony Audio high performance power cable, which there's nothing high performance or quality about it. So this is all completely done wrong. So we're going to do it right. We're going to install new amplifiers into the seat. The power and ground from the amplifier is going to run to the distribution block. From the distribution block, we're going to run power and ground directly to the new battery that we're going to install. And then to help the bike charge better, we're going to go under the hood. We're going to do the big 3. So we're going to upgrade the factory feed wire from the alternator to the battery. We're going to upgrade the factory ground feed from the alternator to the factory frame bracket, and then from the frame to the battery. and that's just to help the bike on the factory side run more efficiently, and that's going to help with the battery drain issue. Then all our current draw from our amplifier is going to run directly to the new battery. So, I know the video's kind of long, I apologize, but it's just stuff that I felt should be common knowledge, and it's not, obviously. And be careful who you let work on your bike. They took the power cable and threaded it in through the factory ring terminal and wadded it up with a wad of tape. Obviously, that's not the right way to do it. So, you saw the disaster. You saw what I'm up against. I'm going to start fixing it today. I'm going to clean it up and show you the proper, safe way to do this. Now that we've completely removed the battery, it gets even worse. So there's their battery cutoff switch with the loose cables on it. Then leaving there's a wire off the fuse block, and then the factory ring terminal that used to be on the battery, and look what they did. You can't make this shit up. This is crazy. Now, what the hell is the excuse for that? I've seen some ghetto rig stuff where they put a ring terminal and then they put a bolt through the 2 ring terminals. Damn, not even that. Holy crap. You can't be serious. Look at these wires under the bike, unprotected. That one goes around to that side, to the amplifier and to the passenger side. That's a speaker wire to the headrest pod. I guess that's one way to keep the wing nut from spinning off. One other thing I got to nitpick at is this radio install. We like running weatherproof radios or the Sony head units in these slingshots because it helps with the glare and the buttons are sealed. We sell a lot of Pioneer head units, but always in cars, never, ever, ever on anything that's going to be outside, because you sprinkle a little bit of water on the Pioneer head units, all those buttons on the bottom stop working. Anybody that's ever put a Pioneer in a Harley or a Slingshot knows you get a little bit of water, those bottom button keys don't work. You got to use the remote. So the installer's answer was he glued the radio in and just made a little trim piece with hot glue on the bottom because the radio kit was too expensive and it was $400. First of all, it's not your money, it's the client's money. So if the client chose not to spend the money, I would understand. I spoke to the client, he said he was never given the option. Second of all, just a quick search on the internet, Crutchfield Buying Retail offers 2 kits, one for $49 and one for, I think, $79. So guess you didn't do the research, or maybe you weren't telling the truth and you didn't check it all. So they sell them a double-din radio with a CD and DVD slot, which can't be used because the radio's glued in place and the face won't open. So if you look in the corner there, on that corner in there, the radio is wider than the opening, so there is no way that that radio could possibly open up because it's hitting the dashboard. And then at this angle, you can't even see the top half of the radio. So when you're sitting like this. So that's not gonna work. We're gonna have to fix that. And then I haven't even pulled the radio out yet, but you could see the mess of untaped wires in there. I see the green emergency brake wire. I see the RCA cable. I see red and black speaker cable. And just as I suspected, drywall screws, and look at this, more glue. Wait till you see how long this screw is. More, 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 more. Are you serious? Are you serious? And the kit came designed with a machine screw. So the kit machine screws into here. And they said, fuck that. Threw that away and just drove a 3-inch drywall screw through the kit, through the mounting plate, and through the dashboard. Hey, that one wasn't holding anything at all because they missed. Let's see what's under the skirt. Not as bad as I thought. I guess they used 20-foot RCA cables, went 12-foot would have reached. Got some bare wires in here. Hey, I've talked about this in the past. The emergency brake wire is not hooked up, which means the customer is never going to be able to pair a new phone if he gets a different phone, because it needs you to put the emergency brake up to go into the Bluetooth menu. I literally just made a video about this. You can use a TR1, a TR4. It's a $10 part that allows the customer to access his menus. I guess you don't care about the customer, so he doesn't get that. Tapped into the factory harness when they make a radio harness for this. And then you went and cut, I don't know why, but the bottom here is cut up. Oh, it looks like you used a soldering iron to cut it too, because look, 1, 2, 3, all pointed melt marks. Look at that. So I guess you didn't have the right tools, so use a soldering iron to burn through the dashboard and hot knifed it. That's my, still recording? That's my ghetto alarm alert. Ghetto, 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 ghetto. It's detected. We got some more fixing to do. Okay, so in closing, I just want people to understand we're constantly building cars and motorcycles, and we pride ourselves on trying to do everything the best way possible. So if you take your time and use I don't understand when people use cheap speaker cable, cheap power cable. Like, always use name brand wire. What people don't understand is when you take shortcuts like that, you're robbing the amplifier of power. So you're bragging that you put a 3,000 watt amp in the car, but the 3,000 watt amp is doing 900 watts. So how about you do a 1,200 watt amp and wire it properly? That way the customer gets 1,200 watts. So you get away with it a lot on cars because you have a big battery and you can do multiple batteries and you can upgrade the alternator. You do not get away with shortcuts on motorcycles, on slingshots, because we have a very limited amount of current to begin with. So there's not a lot of power. It takes power to make power. An amplifier would only give you out what you put in. So if you give an amplifier a little bit of input power, it will give you a little bit of output power. So then people are putting 2, 3, 4, 5,000 watts and keeping the electrical system stock. We don't like to build anything over 3,000 watts because there is no factory electrical system that can handle 3,000 watts. And then you start getting into custom alternators and 4-gauge, 0-gauge runs, multiple runs, and then frame rail upgrades. And then you're spending thousands of dollars to upgrade the electrical system for not that much more output. So we like to keep everything under 3,000 watts RMS. That way you could do a lithium battery upgrade, you could do 0-gauge runs, and the amplifier will give you, if you build a really efficient enclosure in a car, you can get a ton of output. If you put the sub in the wrong enclosure, you can put a 5,000 watt amp on it and not get any output. So pay attention to small details. Use really good wire. Solder your wire. Make sure you're using high quality connections. Make sure you're feeding DSPs. We run DSPs on everything. We're definitely putting a DSP on this Slingshot. So if you're giving the speaker the signal that it wants through the DSP, it's going to play louder. So instead of running 200 watts to a speaker and letting it play down to 20 hertz or 50 hertz, and then it's a mid-ranger and letting it play up to 20,000 hertz, when it only wants to play from 200 hertz to 2,000 hertz, speaker's going to play louder and be happier and not blow up if you give it exactly what it wants. So how about you pay a little more attention, you pay attention to the specs of the speaker, You give the speaker the frequencies that it wants. You give the amplifier the amount of current that it wants. And the amplifier won't heat up. It won't shut off. It won't blow up. The system's going to play louder. The Slingshot that got this customer to bring his bike to us was less than 2,000 watts RMS. We used an 804 and we used a 1200.1. Not crazy power. He was happy with the bass. He was happy with the way we made 4 mid-ranges sound. The bike was louder and cleaner than his bike, and he's running more power and 3 times more speakers. So we were able to do more with less. So at the end of the day, take your time, use quality wire. That's another thing I don't understand. We're doing builds for $5, $6, $7, $8, $9, $10,000. When I give the estimate in the quote, I've always had customers go, oh, can we use less expensive speakers? Can we use less expensive amps? There is not one time I have ever had a client go, $300 is way too much for high quality wire. Give me cheaper wire. That has never happened. So I guarantee you, you guys are not giving the customer the option. There is not one client I know that would say, give me the $100 wire instead of the $300 wire, so my 3,000 watt amp only does 2,000 watts. That'll never happen. So, hope this helps. Let me get back to this build. Talk to you guys later.